Hello to everyone. Thank you for coming for today's journal club. I wanted to share with you this interesting paper on schema and its impact on uh, item and contextual memories. First of all, let's figure out what is the schema. Uh, According to a neurophysiological definition, it is a network of neocortical representations that are strongly interconnected that can affect online and offline information processing. Uh, the basic uh, neurophysiological experiments conducted in animals show that when special associations are formed for flavors and locations pairs. After a lag of 2 days, animals with destroyed hippocampus can learn quite well new associations uh, if they are consistent with the learned schema. But the uh, the concept of schema was introduced much earlier, at the beginning of 20th century by Swiss psychologist Jean Paget. He suggested that we try to understand new experience using our old schemata, just plural for schema. The assimilation incorporates those new pieces of knowledge into pre-existing schemata, while accommodation is the modification of the old schema so that they can cover well the new knowledge. What is this, in your opinion? For those who is not aware, I can introduce you. This is agreeable. You see, it has Borges, Quiff, and Dance, quite rich material, but it doesn't fit any schema you have so far unless you experience a series of those greebles. And then you figure out that they can actually form families and they can be separated into sort of genders, which are called lock and glebe. It's quite funny. You see, this is the same gender from the same family, which is called Tasio. Um, and this is a nice example of a new schema that is acquired via experience. Memory schema is different from other knowledge structures. At least it was well discussed by Ghosh and Gilboa in their review. And there are a few important criteria. First of all, it is an associative network structure, which we have already discussed. It is based on multiple episodes. It is a result of learning. Very important, and this is a critical detail, it lacks details. It is quite vague, quite abstract. It is a summary of our reality. And it's adaptable. So if reality changes, then the schema changes as well. Look at this picture. It's quite rich. Now try to recall and to write down, if you can, or just keep it in mind, 6 elements of this scheme. For those who is not familiar, it is particularly interesting. So I hope everyone is more or less ready. Now let's get back to the picture. So it's almost obvious that you were able to recall chairs and tables, maybe also windows and computers, though there were no windows and computers in this scene. But for sure, only the minority of those who saw this picture for the first time recognized skull or a bottle of wine, which is not a part of the schema of the office, while a window or a computer are. And this is a nice representation of how actually schemata works. Schemata guide our behavior. They make complex things simple. They allow to adapt to rapidly changing world. They organize our knowledge. They structurize our knowledge, and they help to recall. As a congruent or incongruent elements of the scene can be actually well encoded, but via different mechanisms, as it is discussed in the review of Lyon and Casteran. The congruent exploit mostly cortical circuits. They rely more on medial prefrontal cortex, which, while activated, suppresses medial temporal lobe. While in case of incongruent, you see it's a bakery shop and it is a duck. It can also be quite well remembered, but exploiting medial temporal lobe and not medial prefrontal cortex. But in some cases, schema can be particularly the schema can not help, but on the contrary, it can block our memories. And this is what is studied in this paper I will discuss in detail today. First of all, the authors asked participants to understand few simple rules of association between the simplified houses and various phases. Those rules are quite simple, and this is one of the examples. Stout, which is heavy, obese, and no headwear phases, which are all of those. But not only those. There can be much more phases of this kind generated by their software. They are consistent with the caravan. Aged, no headwear, with the castle. Stout and aged, other combination of the features, with the church. Later, at the first day, they made subjects to have some training on categorization of the new phases. And they used this simple layout of 6 potential houses. This one, and this one are consistent with schemas. Those are just have no rules behind them. And in this particular case, since we have aged phase with no headwear, the right choice is the castle. And it is highlighted in green since it is the feedback of the right choice. After this, they had 1 day of rest. And on the next day, when the schematic knowledge is thought to be more consolidated, they did the main experiment, which is the learning experiment, as they call it. First of all, they ran an encoding of new associations with new phases, but according to the old rules. Then there was a face recognition task. Is it a new or old phase? And after all, contextual memory task, during which subjects had to identify the learned contextual location of the house paired with the old face, which is shown on the screen. Let me explain once again so that it is more clear. This is the learning and coding session. It's a new, old, no headwear phase, and those are congruent, schema congruent homes. And according to the schema, this one, the castle, has to be selected. And it was selected, and it's correct. And there are in total 72 faces. 72, half of them are congruent with one of the possible schema congruent homes, and the other 50% are just random. So face recognition task is simple. They're shown with a face, and they have to recognize whether it is old or new or similar to the old. And the contextual memory task is the task when they had to choose one of the locations, which is consistent to something that happened in the past. So now they select this location, and it is highlighted in red because it's wrong. The right choice would be this one. So the behavioral results are quite interesting. First of all, they confirmed that actually participants learned the schema-related rules, and they have done much better on schema congruent associations. This is the encoding phase still. And then the recognition task. They had to recognize the faces that they experienced during this encoding phase. And what is extremely interesting is that memory discriminability was much better for incongruent condition. So if the judgments on the consistency with places was more difficult because there is no background of schema knowledge, then the memory encoding of the face itself is much better. And the accuracy of the contextual memory is also much higher for schema incongruent faces. If you have the knowledge of the schema, you don't care about the features of the faces, you don't care about the features of the locations. You go straight ahead and you do the right choice. If you don't have this support from the schema, you have to study more carefully both the space and the features of the face. And that is why the encoding is more detailed, more deep. This is the table of the results where they show that schema congruent faces are recognized. The percentage of the hits is significantly lower than for schema incongruent. In addition to behavior, they collected event-related potentials, and those results are quite consistent with what they show at the behavioral level. They demonstrated this late parietal positivity, which discriminates incongruent and new faces, while the congruent ones are sort of in between of those. And there is a significant difference in this right parietal region of interest between incongruent all and congruent all, with incongruent differing more from the new. They interpret it as a stronger memory trace related to incongruent schema independent items, faces. To the presentation of the face. No, it's just the face recognition. Yes. It's this this one. Face recognition task. Very simple. They have 72 faces, 72 lures, and 72 new faces. New faces are those which are totally new and not consistent with the congruency rules they have learned before. The lure phases, they similar to the rules which they have learned, but they have not been shown at the preceding phase. I hope that I didn't mislead you at this point. I will check the paper later so that I am really convinced that this is the correct guess about the ERPs. So the last findings I wanted to share with you is that there is a correlation between the strength of the contextual memory and the ERP amplitude for incongruent elements. The stronger is the contextual memory, the greater is the amplitude of this familiarity or memory-related component from the same region of interest. So the main conclusion is simple. Schema-induced shallow encoding restricts memory formation for goal-irrelevant information. Thanks for attention.